Okay, so let's talk about ester and amide formation. We make these by having a reaction between a carboxylic acid and alcohol. So for number one, acetic acid and ethanol. What that gives us is ethyl acetate. Ethyl acetate. When we come down here, 1, 2, 3, 4, this is butanoic acid and ethanol, so it'll be ethyl butanoate. All right. When we start talking about a reaction to form an amide, it's carboxylic acid, and that's going to react with an amine, a nitrogen containing compound. And we go through and get the same thing. All right. Now, the number of R groups on the nitrogen is going to be dependent upon what sort of amine the acid reacts with. If you've ever heard of DEET, the mosquito repellent, that's NN-diethyl-3-methylbenzamide or NN-diethyl-M toluene, all right? Toluamide, depending on which name you use. But what that is this right here, 3-methylbenzoic acid, and you get here, this is two ethyl groups on this nitrogen, and this is our compound right here. That's DEET. It will repel insects. Now, what's important here, because this is how we break down proteins and it ends up being part of our protein synthesis, is it's the hydrolysis of esters. So we're just adding water here. All right. Now it's got to be water under the right circumstances. And so what I've done here is I put the ester right here. Okay. And if we add water, what we're back with is the carboxylic acid and the alcohol. Now, for the amides, when we add water, we're back to the carboxylic acid and whatever amine we started with. So here for number one, ethyl propanoate, ethyl, right, 1, 2, and then propanoate. When we add water, this O, we have our H attached to it now, and we get an OH attached to this two carbon chain, and that's it. So these shouldn't be too bad. When we do the amines, or the amides, excuse me, we get this right here, benzamide. We add water to it, we get our benzoic acid and ammonia coming off. You should be able to do these blue ones as well. Penicillin sort of works under this premise. The way that this works is you have an OH group and this guy right here, which is like an amide, but it's circular. And when it reacts, this is what we get. This part opens up right there. And in doing so, what that does is it doesn't allow bacteria to sustain a cell wall. Now, obviously, some bacteria are not affected by penicillin anymore, and that's why we've developed other drugs. And lastly, page 625 has a nice layout of all the reactions we just talked about. You need to review this. It's going to be helpful. The book is there as a tool for you. All right, so page 625.